Hello there everyone. Today we will talk about the LeetCode problem 3513, number of unique XOR triplet 1. Okay, this is a medium mark problem, but it's too easy if you found the pattern. Okay, so what the question is given, there is already given nums of array, which is told that the size of the array, which is let's say n, then the nums will contain n elements starting from 1 and ends with n, and those elements may be shuffled here and there or maybe in ascending or descending in any order, but each the array of nums contain n elements and each element will be unique in itself. Okay, let's say for example here the size of the n is 3, so that's why it contains only 3 elements which is starting from 1 and ends with 3 and 1 2 3, and each digit is unique, right? So what we have to do in this whole question, see, you have to find the unique XOR triplets. So XOR, you already know the symbol of XOR is like this, and you already know the XOR table, right? 0 0 XOR 0 is what? It's 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is 1, and 1 XOR 1 is 0. And 0 XOR 0 is also 0. Okay, so keeping this in mind, what we have to do is that you have to find a triplet. Okay, let's say the triplet is A, B, C. Okay, or let's say nums of I, nums of I, nums of J, and nums of K. Okay, let's see. Let's say these are the valid triplets. So the condition is I must be less than or equals to J, and J must be less than equals to K. Okay, so these will be triplet, and we will take their XOR, like nums of I. XOR symbol is like this in C++. Nums of J and XOR nums of K. The brute force way is to use 3 for loop, and we will run those loop, and we will take a set, an ordered set, to track the unique digit number. Okay, or anything you can take. I will consider a set. I will store all these elements in the set, and I will just simply in the last return set size. Okay, that's the brute force way. Definitely you will get the result, but the seeing the constraints, it was 10 to the power 5, right? So you cannot use that brute force approach. So as you can see, let me find out the pattern. Okay, so if you see for this one, okay, so what is the number of unique triplets in this array? Okay, 3 1 2. Let me find out. So the array is 3 1 2. Okay, so what can be the triplets? Seeing the condition I, J, K, where nums of I can be less than equals to nums of J less than equals to K. So in ascending order, or you can directly say the next element must be greater than or equals to the previous element. It must be in such a way. Not the index will be in such a way. Okay, not the element, the index. Okay, so what can I do? Taking the index, considering the index. Okay, so the first can be 3 comma 3 comma 3, right, as 0 comma 0 comma 0, right? The index 0 1 2, the index 0 0 0, I can take 0 0 0 index, so that's why 3 3 3. I am directly taking the values. Okay, other possible way is 3 comma 3 comma 1. Yes, and then 3 comma 1 comma 1. Then what, 3 comma 3 comma 2, then 3 comma 2 comma 2, and then 2 comma 2 comma 2, here 1 comma 1 comma 1. Okay, let's take out this XOR. So in this 3 XOR 3 is 0. Let me do it here. So 3 can be represented as, this one is 3 in decimal binary. Okay, 3 and 3. If I do the XOR operation, so 1 and 1, XOR operation is 0, 1 and 1 0, so it is 0, and 0 XOR 3 is, it's 1 or 0 1 and 0 1, so this will give us 3. Similarly 3 XOR 3 is 0, and 0 XOR 1 is 1. Okay, this is also unique, this is also unique. What about this one? So the XOR is commutative, right? If you do A XOR B XOR C, okay, if you take this, then the whole this, it will be equals to A XOR B XOR C. Okay, so if I take as like this, 1 XOR 1, that is 0, then 0 XOR 3, it is again 0. Okay, 1 XOR 1 0, 0 XOR 1, it's 1. Okay, now here 3 XOR 3 is 0, 0 XOR 2 is 2. Okay, now 3 XOR 2 is 2 XOR 2 is 0, 0 XOR 3 is 3. Yes, 2 XOR 2 0, 0 XOR 2 is 2. Okay, I think 1 is left. 1 2 3 4 5 6 7, 2 power 3 8, 1 is left, that is 3 2 1. Let's take this one. So 3 XOR 2, so 3 XOR 2, so it will be 1. Okay, 1 XOR 1, it's 0. So okay, this is also unique. So finally I got all the unique numbers after from the unique triplet. The unique what I say XOR are 0 1 2 3. So I got 4 unique XORs from the triplets. Okay, so the answer will be 4. Okay, what I do, I just make the triplets, okay, all possible triplets, based on the condition that the 0 I j k condition index, where I must be less than j less than k. Okay, that condition, what I do, I just do the XOR operations, and then what I have done, I just find then the store then the result. This was the brute force approach. Okay, right, definitely doing making triplets, all triplets, and then finding the XOR, then storing in this set and something. It's kind of brute approach, right? So as you can see here, you can notice something, right? The result of the XOR, okay, can you see, if I do the XOR, the binary representation of the resulting XOR, that is, if I do this, as you can see, the binary, these are all the XORs, right? So what is the bit width? That means 3 can be represented in 1 1. Okay, 2 can be represented in 1 comma 0, means 1 0. 1 can be represented as 1 or 0 1. Okay, 0 1, and 0 can be represented as 0 0. So anytime you haven't seen that doing XOR, there will be 1 bit extra, right? The bit size of XOR, resulting XOR, will be same as the operators that you will be operating. The maximum size of the XOR will be the maximum value, right? Let's see, what if I do the XOR of let's say 5 or 4, and if I do the XOR of 6, maybe 6, okay, 4 5 6. Okay, what if I do the XOR 0? It will be 0 0 0 0 and 1 1 1 1 0. Okay, what is this? It's 2, but it can still be, it is smaller, but it can be represented as in the form of 3 bits, but it cannot be represented. No result will come that will be represented in 4 digits, that will require 4 digits. Okay, what I'm trying to say, the result of the XOR will always be less than maybe or equals to the maximum size of the all operators. Okay, so what I have done here, okay, the array, let's see the array. What I have done, as you can see, every element of the array, you can find those the result of the any triplet. Okay, if let's say there are 3, right? So the possible combination all will be 8. In those 8 possible combinations, there will be some combination of or some permutation which will be unique, right? And if I take those triplets, let's see here, these are all the 8 combinations, right? And in these 8 combination, there were some unique combination which I have taken as XORs, and then those were the results, right? And then I count them, what were the unique, and then I return. So the result, what I am talking, if I do the XOR of these 8 triplets, 8 combinations, if I do the XORs of each combination, then the resulting XOR will be of the same size, of the same width as of the largest value in the triplet. Okay, if I see here 3, the 3 answer is 3 of XOR, the 3 is the XOR of 333. Okay, so the width size is same because 3 is same, of course. Okay, what about this one? 1 is the XOR of 3, XOR 3, XOR 1, right? So the size of the width 1 is smaller, right? It is not greater, right? Similarly, if you take in any triplet, the resulting XOR will be the bit width of the resulting XOR will always be same or less than all the operand. Okay, so for this, how you can move to the answer? So we already concluded that if I see here, the 3 is the maximum value, right? So its bit width is 1 1, so that is 2. That means the answer, the unique, the unique XORs, whatever the unique XORs will be, it can be represented as of bit width 2, right? So there are 8 possibilities, and in those 8 possibilities, like the bit width is 2 of size 3, which is maximum value. Okay, so what can be that? 0 0 0 1 1 2, right? Something 1 0 1 1, right? This all can be represented. So if you take the if you do this all combination count, that will be comes as the answer. Okay, so what I have said, the the maximum value of this array, that is 3. Okay, so all the size whose bit width is, you can count, right? So what I am trying to say, the width size, bit width of maximum value in array. Okay, if you take to the power, that means let's say its bit width is m. Okay, so if you do like this 2 to the power m, this will be the uh, count of the unique XORs. This will be answer as count of the unique. This will be count of the unique XORs. Okay, this will be your resulting answer. That this was the real pattern. Okay, if I do this here 3 1 2, then 3 is the maximum value. This can be represented as 1 1. What is this size? Is 2. So if you do 2 to the power 2, that is 4. This was the answer. Okay, if you do like 1 1 2 3 4 and 5. Okay, if you do this, so the maximum value is 5. The 5 can be represented as 101, right? So the answer will be 2 to the power 3, that is 8, and it will be 8. You can check it out. Okay, this is such a small problem with little information of XOR. If you have information on XOR, you will definitely get this problem. Okay, it's so what can be the XOR of 1 to 7? Okay, what can be the XOR of 1 2 3 4 5 6 7? So how you will find it? Simply the maximum value is 7. It can be what is the minimum width that can be represented, that can be held to represent 7? Minimum width will be of 7 will be the 7 can be represented in the form of like this, right? So 3 size, so 2 to the power 3, this is the answer. Okay, you can use the power function. Maybe it give time limit, I don't know, but there is a better operator, bit operator. If you do like this, left shift operator, and the value, let's say the size was 3, right? If you do this size, then this will give you the answer. Okay, by doing the left shift operator, it is equivalent to 1 into 2 to the power size. Okay, this is additional info. And if you do like this, one right shift operator size, it will give you like 1 divided by 2 to the power size. Okay, got it? So this was all, and this was the code. Okay, as you can this is only valid for 2 greater than 2 digit, but for 2 digit like 1 comma 0 or 0 comma 1, this will be, if you find the XOR of let's say 1 comma 2, right? 1 comma 2, so the XOR of 1 comma 2 is 2. You can easily find out 1 0 and 0 1. This is 1 1 0 and 1. This is equals to 1 1, right? So the XOR is 1 comma 1. This is equivalence to, this is what? This is 3, right? This is 3. Okay, what then the other combination of 1 comma 2 array, if this is array. Okay, the possible triplets will be, sorry, the possible triplets of 1 comma 2 array is 1 1 1. Okay, 1 1 2. Okay, 1 comma 2 comma 2. Okay, and 2 comma 2 comma 2. So here it will be 1 comma 1 XOR 1 is 0, 0 XOR 1 is 1, 1 1 0, 0 XOR 2 is 2, 1 2 XOR 2 is 0, 0 XOR 0, 0 XOR 1 is 1. It is again 0, 0 XOR 2 is 2. So the result unique number of unique XORs is 2. But what if I go to through this way? So the maximum value is 2, right? So 1 comma 0, the bit width is 2, then to the power 2 is, that is 4. this comes 4, but the answer is 2. That's why the size must be less than must be greater than 2. If it is less than or equals to 2, the XOR will be size of that array. Okay, so that's why I have written here, if nums.size is less than or equals to 2, you should return the same size. Okay, what if the array size is only 1? Then definitely it will be the XOR will be the same. Okay, 1 only. 1 and 2, I have already computed, it's 2, but by computing this way you will get 4. That's not correct. So that's why there is what I say exception. Okay, now why I am shorting it, I am trying to find the maximum value, because all smaller values can be represented in those bit width of the maximum digit, right? 1 can be represented in the form of 5 digit bit width, right? 0001, like this. That's why I find the in descending order. I have, and then the largest element will comes on the 0th index. I have taken it out. I computed this with the bit width. You have to typecast the number integer into the unsigned integer, then bit width will work. I have computed the width, and this is the way which is equivalent to 2 to the power width. Okay, this is a left shift operator. Okay, hope you get it.